Hello, in this video we're going to go over scientific notation, which is a way to express really large numbers and really small numbers in a simpler way. But before we do that, we're going to go over prefixes, which can also be used to simplify larger or smaller numbers. Now, the table down below lists many different prefixes. The three that you'll need the most for chemistry are the kilo, centi, and milli. So I would go ahead and memorize those three. You'll see them a lot in chemistry, but we're going to go over each of these because we do use the SI system, which is based on the metric system in chemistry. So it is good to kind of know where these prefixes are coming from, what they're equal to, and how we can summarize larger and smaller numbers or abbreviate them. So in the table down below, the first prefix is mega, which is given the abbreviation capital M. And mega is equal to 1 million times something you're measuring, right? The next one down is kilo, and you might be familiar with this one. So for example, let's say you've walked 1,000 meters. You could also say that you walked 1 kilometer or kilometer. So again, kilo is equal to 1,000. So we're just replacing that 1,000 with the prefix kilo. And it's just a little bit of a different way to express that number. Now, the next prefix is deci. We really don't use this at all in this class, so don't worry about that one. But it is equal to 1/10 of something. Centi is equal to 1/100th of something, and you might be familiar with centimeters. So let's say you've measured something to be 1 centimeter long. You could also say that that is 1/100th of a meter. So it is easier to say centimeter than 1/100th of a meter, right? So that's where prefixes do come in handy. The next prefix down is milli, which is abbreviated with a lowercase m, and it is worth 1/1000th of something. So if you have a millimeter, that would be 1/1000th of a meter. And then you can see that we can go even smaller. So if you have a micro of something, that's 1/1,000,000th. Nano, even smaller. Pico is even smaller. Now, micro, nano, and pico are prefixes that I would say are more commonly used in biology because you're describing really small things sometimes like cells, and those are typically measured on that scale. But in our chemistry class, we'll really be focused on kind of those middle prefixes, so kilo, centi, or milli. So definitely know those. And then the column on the right, this is showing how to write those numbers in scientific notation or something close to it. So for example, mega, which is equal to 1,000,000, we could also write that as 10 to the 6th. So 10 to the 6th just means that we're multiplying 6 tens together. And again, if you plug that into your calculator, that will come out to be 1 million. Now, the other handy thing with this that I really appreciate is we're multiplying 6 of these tens together, and 1 million has 6 zeros. So that's another way to look at it. If we look at kilo, which is worth 1,000, we could rewrite 1,000 as 10 to the 3rd because we have 3 zeros. Now, when we get to the smaller units or the smaller prefixes, instead of positive exponents, we now have negative exponents. So, for example, if we look at 1/100th, another way that we could write this is 1 over 10 to the second, because we have two zeros in 100, right? But you might remember from your math courses that if something's in the denominator, and let's say we want to bring it up into the numerator on top, we have to change the sign of the exponent. So 10 to the second is in the denominator, but if we want to bring it up, we're going to put a negative in front of the exponent. So now it's 10 to the negative 2. And that's going to be the same for each of the smaller prefixes and their amounts. So you'll notice, for example, 1/1000th, it can be rewritten as 10 to the negative 3. So smaller numbers have negative exponents, larger numbers have positive exponents. And that's actually going to bring us into scientific notation. So again, this is a system for expressing very large or very small numbers in a compact manner. And it uses the idea that such numbers can be rewritten as a simple number multiplied by 10, which is raised to a certain exponent or power. So for example, we have positive powers of 10, and notice that these are all larger numbers. So we have 10 to the 1, which is just equal to 10, 10 to the second, which is equal to 100, and again we have the value 2 and 2 zeros. 10 to the third is 1,000 with 3 zeros. 10 to the fourth is 10,000 with 4 zeros, and that goes on, right? And then we also have negative powers of 10. So 10 to the negative 1 is equal to 1 over 10. 10 to the negative 2, which we just saw on the last slide, is equal to 1 over 100, and so on and so forth. But also notice we can write this as a decimal. So instead of 1/10, we could express that as 0.1. 1/100th is 0.01, and we could keep going. All right, so that brings us to some rules for scientific notation. So in scientific notation, we always have what's called a coefficient, which is represented by a capital M. And then we multiply that by a power of 10. So we have our base 10, and then our exponent, which is represented by a lowercase n. Now, the coefficient, that capital M, must always be greater than or equal to 1 and less than 10. So another way of writing that, let's say we've got our capital M. This has to be greater than or equal to 1 and less than 10. So for example, we can't have a coefficient of 0.5. Or we can't have a coefficient of 12. They're either too small or too large. It has to be between 1 and 10 or equal to 1. So one example is shown down below. We have 3.4 times 10 to the fourth. So if we want to write this in standard notation, so just as a normal number, what I typically do is I write 3, 4, and then I move the decimal point over 4 positions, which is the exponent. So 1, 2, 3, 4, and then I fill those blank spaces with zeros. So what this value actually is, we have 34,000. But sometimes it's a bit difficult to write those larger numbers, so scientific notation is one way to simplify the number. So instead of writing out 34,000, we can write it as 3.4 times 10 to the fourth. Now, later on, we'll also see another use for scientific notation, which has to do with something called significant figures, but we'll get into that in the next video. Now, let's look at some examples of scientific notation. So I have our little reminder of how to express scientific notation in the upper right. And let's try to express 1,250,000 in scientific notation. All right, so let's do this one together, and then you can try the next one on your own. So for the first one, remember our coefficient m has to be between 1 and 10 or equal to 1. So I'm going to move this decimal point on the end over until I hit a number that's between 1 and 10. All right, so I'm going to move it once, twice, 3 times, 4, 5, 6 times. Because if I write 1.25, that is between 1 and 10. So I have my coefficient. Now I need to figure out what my exponent is for the base 10. Now, I just moved that decimal point 6 places over in order to get my coefficient. So that means my exponent is 6. So I moved the decimal 6 places. And so that gives me my exponent. Now, again, remember, if we have a larger number like this one, which was greater than 1,000,000, right? So this is larger number. That means we have a positive exponent. The other way to think about it is that the decimal moved to the left. So I'll just add up above that we moved the decimal 6 places to the left. So that's also going to give us a positive exponent. So whichever way helps you remember the scientific notation rules is totally fine, however it makes sense to you. Now, in the second example, we have express 0.0000233 in scientific notation. So notice that this is a really small number. This is a decimal, right? So we should expect our exponent to be negative. So we have a smaller number, so we expect a negative exponent. Now, see if you can figure out how to write this number in scientific notation on your own. So you can pause the video, try it on your own, and when you unpause, we'll go over it together. All right. So again, we're going to move that decimal point over until we hit a number in between 1 and 10 or equal to 1 for the coefficient. So we have to move this once, twice, 3 times, 4, 5 times, right? So our coefficient is 2.33, and then we're going to multiply by 10, and our exponent is equal to how many times we moved that decimal point. So we moved it 1, 2, 3, 4, 5. But remember, this is a smaller number, so it's actually going to be negative 5. All right, so we moved the decimal 5 places to the right. So that's another way to remember the rules. If you have to move your decimal to the right, it's going to be negative, or you're going to have a negative exponent, I should say. If you move your decimal to the left, you're going to have a positive exponent. Or you can just remember a larger number has a positive exponent, a smaller number has a negative exponent. All right, so now try two more on your own. Pause the video, see if you can write these values in scientific notation, and when you unpause, we'll go over them together. All right, let's start with the first one, 240,000. So I need a coefficient between 1 and 10 or equal to 1. So I'm going to move my decimal 1, 2, 3, 4, 5 times. That will give me a coefficient of, oops, I almost wrote 2.5. That will give me a coefficient of 2.4. And we moved the decimal 5 times. And this is a larger number. So my exponent is positive 5. Now for the second one, I have 0.0035. I'm going to move my decimal so that I have a coefficient between 1 and 10 or equal to 1. So that's 1, 2, 3. So my coefficient is 3.5. And my exponent, let's see, this is a smaller number. It's a decimal, so my exponent will be negative, and I moved that decimal 3 times. So I have negative 3 as my exponent. All right, so again, this is just a way to express larger or smaller numbers in an easier way. And as I mentioned before, it's also going to help with something called significant figures later on. So there is another purpose to this as well, but we'll get into that later. All right, let's practice going in the opposite direction. So what if we're given a scientific notation value and we need to write that in standard notation? So let's look at this first one. We have 3.4 times 10 to the negative 6. Okay, so the way I usually do this, and if you have a different way of doing this, that's okay too, as long as you get the right answer. I'm going to write 3.4, and then I'm going to move my decimal 6 times, but I need to figure out if I'm moving my decimal to the left or to the right. Now in this case, I have a negative exponent, so I know this is a really small number. So I'm going to move my decimal to the left. Once, twice, 3, 4, 5, 6. Now all of those places will be filled with zeros. And then my decimal will now be next to the last 0 there, or the first 0, depending on how you look at it. So this is equal to 0.0000034. So we've got 1, 2, 3, 4, 5 zeros in there. And again, this just shows how much easier it is to write the value in scientific notation. All right, let's look at number 2. We have 7.91 times 10 to the 4th, and we want to write this in standard notation. So I'm going to write 7.91, and my exponent is 4, so I know I need to move my decimal 4 places. Now, my exponent is also positive, so I know that this is a larger number, so I'm going to move my decimal to the right. 1, 2, 3, 4. And I'm going to fill in those empty spots with zeros. So this is equal to 79,100. All right, so let's see if you can do this on your own. Let's see. Oh, there we go. So see if you can write 1.2 times 10 to the negative 3 in standard notation and 4.11 times 10 to the 1 in standard notation. So pause the video, try it on your own, and then we'll go over it together. All right, so the first one, 1.2 times 10 to the negative 3, I'm going to write my coefficient, and my exponent is 3, so I need to move my decimal 3 places, but it's also negative, so I'm going to move it to the left so that I get a smaller number. 1, 2, 3. I'm going to fill in these empty spaces with zeros. So this will be 0.0012. And the second one, we've got 4.11, and our exponent is 1, so I'm going to move my decimal only one place. And this is a larger number because I do have a positive exponent, so I'm going to move this to the right. So that gives me 41.1. Now, this last example, writing in scientific notation might not be easier. Writing 41.1 is easier. But it just goes to show that you can write any number in scientific notation. Okay, so let's talk about how to multiply in scientific notation. So let's say you have two numbers that are both in scientific notation and you don't have a calculator handy. How do you multiply them together? So down below I have just generic numbers, a times 10 to the y, and then b times 10 to the z. And we're trying to multiply those together. So the first thing we're going to do is multiply the coefficients a and b together. So a and b will be multiplied together. And then the exponents, y and z, will be added together. So underneath that, I have two actual numbers that we're trying to multiply together. So we have 3 times 10 to the 8th multiplied by 4 times 10 to the negative 2. So again, we're going to take those coefficients and multiply those together. So 3 times 4. And then the exponents, again, we're going to add those together. So 8 plus negative 2. So 8 plus negative 2 would actually be 8 minus 2, right? So we end up with our coefficient of 12 and an exponent of 6. But notice that 12 is outside of the range for a coefficient. Remember, our coefficient has to be between 1 and 10 or equal to 1. So what we need to do is put a little decimal here after the 12, and we're going to move that over one spot so that we have 1.2. So that will be our new coefficient, 1.2. Now, since this is a bigger number and we just moved our decimal over, we are going to add 1 to our exponent. So our final exponent will be 7. So remember, larger numbers, larger exponents, right? Okay, so now our final value is 1.2 times 10 to the 7th. Okay, now most of the time the math will work out that you don't have to do any final adjustments. We'll also learn how to do this on a calculator, so that should give you a coefficient between 1 and 10 or equal to 1. But I just wanted to show you an example of how you might need to adjust your value if you're doing it by hand. So let's practice. Let's calculate the following. So see if you can do this on your own. First, you're going to multiply 2.5 times 10 to the fourth by 1.3 times 10 to the third. So pause the video, try it on your own, and when you unpause, we'll look at the answer. Okay, so first things first, we want to multiply those coefficients together. My iPad doesn't want to listen to me today. And then we're going to add the exponents together. So we'll multiply 2.5 by 1.3, and then we'll add 4 and 3 in the exponents. So you will need your calculator probably to multiply 2.5 and 1.3 unless you did it the long way by hand. But that should come out to be 3.25, and our exponent is 7. All right. So let's say you want to divide two numbers in scientific notation. So this will be a similar process, except instead of multiplying the coefficients, we're going to divide the coefficients. And instead of adding the exponents, we're going to subtract the exponents. So very, very similar. But let's see. So a and b are coefficients. We're going to divide a by b. And then our exponents, y and z, we're going to subtract z from y. So down below, I have two actual values. They're the same values from before, but let's say we want to divide them. So we're going to divide 3 by 4, and we're going to subtract -2 from 8. Now remember, when you subtract a negative number, you're actually adding that number, right? So 8 minus -2 is actually 8 plus 2. So we could write that up above just as a reminder. So in the end, our coefficient will be 0.75 and our exponent is 10. But again, notice that the coefficient is not between 1 and 10 or equal to 1. So in this case, we're going to move that decimal over to the right so that our new coefficient is 7.5. Now when we do that, we actually need to subtract 1 from our exponent. We're making this number smaller when we do this. So or the coefficient is actually getting bigger, so we have to make our exponent smaller, I should say. So we end up with 7.5 times 10 to the 9th. So again, we had to make a small adjustment there in the end. Now let's practice. So try to calculate the following on your own first. Again, you might need a calculator to divide the coefficients. And when you're done, you can unpause the video and we'll go over it together. Okay, so again, we're going to divide the coefficients. So we'll divide 1 by 6.7, and we're going to subtract -4 from 6. So if you plug in 1 divided by 6.7, we get 0.15, and then 6 plus 4 is 10. So our exponent is 10. Now, in this case, we do need to make an adjustment. We need to move our decimal over so that our coefficient is in the appropriate range. So our coefficient should be 1.5. But remember, when we do that, we need to subtract from our exponent. So we only moved the decimal one place, so we'll just subtract 1, and we get 10 to the 9th. So in our class, what I'll do is I will show you how to represent scientific notation on a calculator, and we'll go over that together because it is a little bit different based on whether you have a scientific calculator or a graphing calculator. Now, in the next video, we're going to go over significant figures. I mentioned earlier that scientific notation is helpful with significant figures, so we'll see that again. And that will be our last video for Chapter 1. So I will see you then.